Activation. Thread runs within application. Multiple tasks with the application can be implemented by separate threads, which is display, update display, fetch data, spell checking, and answer a network request. Process creation is a heavyweight while thread creation is lightweight. Can simplify code, increase efficiency. Kernels are generally multi-threaded. The benefit is it is responsiveness, resource sharing, economy, and scalability. Multicore programming. Multicore system putting pressure on programmers. Challenge include the dividing activities, balance, data splitting, data dependency, and testing and debugging. Thread management done by user-level thread library. There are three primary thread libraries: POSIX threads, Windows 32 threads, and Java threads. Kernel threads supported by kernel. Example: Windows XP or 2000, Solaris, Linux, Pro64 Unix, and Mac OS X. There are three types of multi-threading models: many-to-one, one-to-many, and many-to-many. Many-to-one, many user level thread mapped to single kernel thread. The example is Solaris Green threads and GNU portable threads. One-to-one, each user level threads maps to kernel threads. Example: Windows NT, XP or 2000, Linux, Solaris 9, and later.
Many-to-many model allows many user level threads to be mapped to many kernel threads. Allows the operating system to create a sufficient number of kernel threads. Solaris prior to version 9. Windows NT or 2000 with the thread fiber package. Similar to many-to-many models, except that it allows a user thread to be bound to kernel thread, which is two-level model. Example: IRIX, HP UX, Pro64 Unix, and Solaris 8 and earlier. Thread libraries. Thread libraries provide programmers with an API for creating and managing threads. Thread libraries may be implemented either in user space or kernel space. The former involves API functions implemented solely within user space with no kernel support. The latter involves system calls and requires a kernel with thread library support.
Issues. There are 5 threading issues. The first and exec system call, thread cancellation, signal handling, thread pools, and thread specific data. The first and exec system call. There are two versions. One duplicate all threads and another duplicates only the thread that invokes the fork system call. It uses depends on the application. Next, thread cancellation. Cancellation may occur in two scenarios: asynchronous cancellation. One thread immediately cancels the target thread. Next, deferred cancellation. Target thread can periodically check whether it should terminate. Okay, next, signal handling. Signal may be synchronous or asynchronous. Synchronous signals is illegal memory access, divisions by 0, and these signals are delivered to the same process. For the asynchronous signal, it's generated by an event external to a running process. For an example, terminating a process with specific keystroke, CTRL plus C. Thread pools, waiting space for the threads or create threads. The advantage is service a request faster than creating a new thread. Bounce the thread in the application to the source of the pool. Thread specific data. Each thread with its own copy of data. It is useful when thread creation process is not in control.
Operating system examples: Windows X3. The transcript of Windows XP threads, synchronization, and deadlock. A synchronization object in Windows XP exists in either a signal or non-signal state. A thread then blocks itself with the wait function and until a specific non-signal object signals itself. Okay, Linux thread. It's in the Linux operation system. Linux threads has a partial implementation of POSIX threads introduced in 1996. The main developer of Linux threads was Javier Riroy. It has been superseded by the native POSIX threads library. Windows XP threads implementations the only 2:1 mapping canon level. Each thread contains a thread ID, register set, separate user and canon strings, private data storage area. The register set, styles, and private storage area are known as the context of the threads. The primary data structure of a thread include a thread, executive thread blocks, kthread, canon thread block, TEB thread environmental block. Linux thread. Linux refers to them as tasks rather than threads. Thread creation is done through clone system calls. Clone allows a child task to share the address space of the parent task process. Structure has task structs, points, process, data structures, shared unique.